At 12 p.m, aircraft A is at the point 200 negative 251 kilometers and is moving with velocity 100I plus 200J plus 0.1 k kilometers per hour. Write down an expression for the position vector of A t hours after 12 p.m. So, the position vector of A is going to be start point 200 negative 251, and then every hour, so we multiply by t, we do 100, 200, 0.1. Now aircraft B is at 0 to 51.5 and is moving with this velocity. So we want the position vector of that. So that's going to be 0, 251.5, and then every hour it's doing 150, 50, negative 0.1. We now want to find the shortest distance between the aircraft in the subsequent motion and the time at which this happens. So if we do ARB, so that's RA take away RB, so 200 take away 0 is 200, and 100t take away 150t is minus 50t. Negative 250 take away 250 is negative 500, and then we've got 200t take away 50t, so that's plus 150t, and then 1 take away 1.5 is negative 0.5, and 0.1 take away negative 0.1 is plus 0.2t. Now, the velocity is dead easy to pick off. All we do is pick off the bits that multiply t, so negative 50, 150, and 0.2. And the shortest distance occurs when ARB dot AVB is equal to 0. So what we need to do is solve 200 take away 50t, negative 500 plus 150t, negative 0.5 add 0.2t, dot negative 50, 150, 0.2 is equal to 0. So we're going to solve, and I always find it's best to put the 0 equals in first when you do this, and then we're going to have a dot product, so vector dot p, and in the top there we'll put the first vector, so 200 minus 50, it's just best to use x, and then we've got negative 500, add 150x, and then we've got negative 0.5, add 0.2x, and then our other vector is going to be this one, so negative 50, 150, and 0.2. And if we do that, then we get 3.3999856. So I'm going to say t is equal to 3.39 and then we want the shortest distance, which is actually going to be the magnitude of this vector. So what we want is the magnitude of 200 take away 50, 3.39 and so on, and negative 500 plus 150 3.39, and so on. And finally, negative 0.5 plus 0.2, 3.39, and so on. So we want the magnitude of that, and so we'll just calculate that. So that's going to be the square root of 200, take away 50 times this number here, squared, plus negative 500, add 150 multiplied by this same result. So just need to get it into the right position. So it's just there, and square that, and then we have negative 0.5, add 0.2 multiplied by the same result, squared. And perhaps I should have been in decimal mode, but I can change it easily enough. Just select it and tap here, and that gives me 31.62. So I'm going to say 31.62 kilometers, correct to 2 decimal places. Now, what time does that happen? So we started at 12 p.m. So what we need to know is the 0.399 and so on. Let's multiply that by 60, see how many minutes that is. So let's say that's 24 minutes. So we're going to say that it happens at 3:24 p.m. We want to show that these two lines are skew, in other words, that they don't intersect. So if they do intersect, then what we would have is that the x-coordinates must be the same. So 2 minus 2 lambda must be equal to 2 mu. And the y-coordinates must be the same. So 3 plus lambda is equal to 1 minus 3 mu. And the z-coordinates are the same. Negative 1 add 4 lambda is equal to 3 plus mu. So let's try working with these two. So equation 1 is 2 minus 2 lambda equals 2 mu. And if we do 2 times equation 2, that's 6 plus 2 lambda is 2 minus 6 mu. If we add these equations, the lambdas will disappear, and we get 8 is equal to 2 minus 4 mu. So 4 mu is equal to negative 6, and mu would be negative 3 over 2. If we substitute that into 1, then we get 2 minus 2 lambda is equal to negative 3. 2 lots of this is just negative 3. So 2 lambda would be equal to 5. Lambda is 5 over 2. Now look at equation 3. And if we do the left-hand side, with lambda is 5 over 2, we get negative 1, add 4 lots of 5 over 2, which gives me 9. If I do the right-hand side, then 3 plus negative 3 over 2 is equal to 3 over 2. So 9 is not equal to 3 over 2. So even if the x and y coordinates are the same, which we got by solving 1 and 2, the z coordinate would be different, and therefore the lines are skew.